we're talking about like probably one of the more pressing things on the planet, which is like, how do we, what is intelligence? How do we come to common sense of things? How do we like navigate our world? And I think creativity seems to come from this privilege of having like a space in here that you will never get in here unless you're really, really bad. And so like creating space seems to be like silence or whatever, seems to be where there's still room.
The Brave Search API brings affordable developer access to an independent index of over 20 billion web pages, powered by real anonymized human page visits to filter out data and refreshed daily with tens of millions of new pages. We'll get started with 2,000 free queries monthly at brave.com/API.
David, it's an honor to have you on the show.
Oh, thanks for having me.
David, you're incredibly well known for category theory. What is category theory?
What is category theory? Category theory was invented in the 40s. It's 1940s. It's about, basically mathematicians were talking about natural this and natural that, but they didn't know what natural meant. And so in order to define this notion of natural that everyone was using, they kind of invented categories, functors, and natural transformations. So, but what is it about? It's about like systems of relationships. So you've got like a bunch of things. So let's say you have a category of things. And what do I mean by that? These things belong together, like fish or whatever, or like things you can eat, or like things that are alive, right? But it's not just that there's a bunch of them, but when you have a bunch of fish, like they relate to each other. And so a category for a mathematician is not just a bunch of things, but also how they relate.
Yeah.
Yeah.
So you mentioned functors and things like two categories. Yeah. Tell us about that.
Yeah. So if you have a whole world of things that relate to each other, let's say numbers, and one number can be less than another number, and you have another system of things that relate to each other, like sets of things, like all the trees we can see or whatever, and that one thing can be a subset of another, like the big trees are the subset of all the trees, the set of big trees. Then there's a functor relating these two worlds, the world of trees of sets and subsets, and the world of numbers. And the functor is called count. So you take your set, you count how many things are in there, you get a number. And when one thing is a subset of another, then the smaller one has fewer things. Like it's kind of obvious. And what category theory likes to do is make what's obvious like a mathematical artifact, so you don't have to hold it. What people in other mathematical fields do is they like hold all the really hard things in their head, and they think you're kind of dumb to be doing like making really hard things obvious. I'm not sure they would really say they'd agree with this, but this is like my stereotype. And in category theory, what we try to do is take all the things that are most obvious and make sure those are really said well. And so functor is this very simple story of like, I have one world, I have another world, and I have a mapping that takes all my objects here, maps them to objects here, takes all my relationships here, and maps them to relationships here. That's what a functor is.
What's the relationship between all of this and, abstraction and complexity?
Yeah. So abstraction is, would you say it's kind of like being able to take some concrete situation and extract something that's repeatable in many contexts? So in math, like, you have lots of different threes. This thing has three, but this thing also has three. And so you want to like extract and say 3 is just a thing I'm going to want to talk about from now on or whatever. So you extract it. But one thing that you do with abstraction is then you can use that abstraction to come back. So someone says like, what's your situation? You tell them, I have too many weeds in my garden. That's just an abstraction now. And then they say, well, try using a trowel or something. Now you bring that abstract idea back to reality and pick up an actual trowel that was like over here and not over here, like this one. And so like abstraction is about pulling back out to something where more people understand what to do, or it's easier to like get your head around what to do, and then coming back and like using that to make a difference.
So what's the difference between abstraction and knowledge?
Abstraction and knowledge. I don't really know what knowledge is. Usually it feels a little bit frozen as like a collection of like, when I hear knowledge, it's like I have these, it feels frozen to me in a certain way. Abstraction feels like a process, and knowledge feels like a an item, but maybe I'm missing what you mean.
Oh, that's fascinating. Well, I think of intelligence as being reasoning efficiency, which is kind of like abstraction efficiency.
Yeah.
So it's model building. It's saying I'm trying to make sense of the world.
Yeah.
And I'm coming up with this model, and then I can share that model with other people.
Yeah. Yeah. So sense making is something I think a lot about, and I think about it in terms of collectives. I think you mentioned Mike Levin before we started.
Yes. Yes.
And he says like all intelligence is collective intelligence.
Yes.
I think all sense making is collective sense making. So whether it's just you and me making sense of like, hey, what's category theory have to do with ML, or whether it's like all the neurons in my brain trying to make sense of something. I think there's something where we give an account. I like tell you something in a language that you understand, not in my own private language, but in a kind of public language. And by doing that, or my neurons are doing that, they're like speaking in this kind of, in a way that like their neighboring neurons probably have some idea what's being said. And by doing that, they can kind of start to account for the what's there and what's not. So like you're saying, you know, I have some new situation, I want to build a model of it. Everyone's like, oh, that's a bear, you know, that's a tiger or whatever. Like, okay, it's definitely an animal. I don't know. So you start to put together like all these different senses of what's going on, like individual senses, but there's something left out. And there's like, no, but why is it switching the Necker cube? Why is it switching or whatever?
Yeah.
And so like this sense making thing is when you like, I see, this is actually, I can see it either way, or this is what it is. And you get a sense that starts to stabilize. And you do that because your accounting settles. Like if, I don't know if you're old enough to know what a checkbook is, but I am. And like we would like, you do this thing where you like, it's settled. I got a 0. The amount I put in was equal to the amount that is in there now. And the difference is 0. And there's something about that where like now you can proceed way more like it makes way more sense as you go. So yeah, I feel like there's something about like accounts settling that makes sense.
There are some beliefs I have. Let's say we're playing the language game now, and we're converging on some understanding, and that might be a private understanding between us. The alternative might be that we're converging on universal truths about how the world works. There's an analytical pathway from the physical world and the knowledge we discover. Whereas another way of looking at it is that we're just discovering all of this complex knowledge, and it's compounding and becoming more and more complex as time goes on. And it's not really grounded by the physical world that we live in.
Right. I mean, I think if we were doing things that were completely ungrounded, it wouldn't work very well, right? Like, so like if in order to do something that's mimetically fit, where in the sense that it spreads and like makes a difference, it has to be something where it's interesting and like relevant to people. Otherwise, they don't have time for it, right? And so I think things can sit for long periods of time where like no one knew about it and it's kind of like sitting there. But those are like kind of miraculous. Like, wow, we found this like secret writings of the, you know, but usually the more common case for sure is that like people understand the value of something within some amount of time. And like, so I think as we're building all this stuff up, if we're not continually compressing it and finding something, not just compressed like a zip file, but compressed in a way that's flexible with like as a model that like we take the submarine and we compress it to something that the captain can like steer so that the captain's like innate ability to think of being a self and like avoiding danger can become like the car or become the submarine. Like as we compress in ways that like fit with the thing we're trying to do, then those are the valuable ones that like people want to share. So I think like we're not just talking about like that building's architecture, you and me right now. We're talking about like probably one of the more pressing things on the planet, which is like, how do we what is intelligence? How do we come to common sense of things? How do we like navigate our world? And I think the fact that we're doing something so universally applicable is because that's what you think will get an audience, right?
Yeah.
And that's what you think people want to hear. And so I think that's not a coincidence. It's like we're only doing things that matter, or we're probably not like really getting to do them very well.
I wonder what the role of physicality is here, because as physically embodied agents, our knowledge acquisition efficiency is higher. There are many just physical concepts in the real world that contribute to abstractions that we use. Embodiment is important.
Yeah.
And if we built an agential AI system, let's say an 11 style collective intelligence, how hard would it be to build that virtually versus having real physical agents in the real world?
Yeah. I mean, I think I heard, I don't know, it seems to no longer be true because they are doing image recognition with AI. But at some point, I'd heard this story about like they gave blind people a camera. The camera created little pinpricks on the tongue or on the back, and if the camera was positioned and just like aiming at something, the people would never learn what it was, or if it just like rotated around the room. But if it was on their head, so that when they turned, it would like the camera would turn with their head,
Yeah.
then they would be able to like actually start to see. And so the idea, so like AI can do this because it just has a trillion of something or whatever, but like this was when you're a human brain, was that like by being embodied, by actually caring about where they're looking and like by deciding that and having the motor as part of the perception loop, they learned in a way they just couldn't otherwise. And so I feel like being an embodied agent, another thing we have that like agents out there don't have is risk. If we didn't have anything that was at risk, if this podcast could not possibly go bad or whatever, or good, then we wouldn't be able to like create, I think. Like there's something about the risk and the care that we put in, like those things seem to be very tightly coupled that like create somehow.
I've spoken with Carl Friston quite a lot, you know, the active inference guy, and he talks about these, like he calls it a cybernetic framework where you have a perception action loop and there's this feedback loop. And the agents, in virtue of just trying to stay alive, they're interacting with the world, so they're kind of modifying their perceptual field, trying to reduce prediction errors, and this gives rise to some very sophisticated behavior where the agents need to learn about the world, they need to understand the world.
I really like that. I really like the idea that like so let's say you're trying to prove things about the world, you're trying to understand the world. One assumption you're allowed to use is that you exist. Like when in math, like you have a theorem, right? And like what is your assumptions for the theorem? Well, like the more assumptions you have, the more theorems you can prove. If you say like, let's assume, you know, that our numbers are between 1 and 10, then you have like tons of theorems like about those numbers because like 4 plus 6 is 10 and 3 plus 2 is 5, whatever. You can make all sorts of theorems. But if you say, I just have some numbers, what do I get to prove? You prove less things. I don't know if that made sense. But the point is, one great assumption is that I exist. Therefore, something like me could exist. So that's kind of a huge assumption you can add for free because kind of like Descartes.
Yeah.
Right. So, and so what I heard from him was like I can kind of assume that since I exist, that gravity must be such that these knees make sense and these lungs make sense. And that what I want, usually, if I really need it, will happen. Because if it didn't happen, I'd be dead already. Right. And so like he kind of uses that to bridge, as I understand it, to bridge utility, like what I want, with what I predict. I predict I can eat that food, and then this idea of like the prediction error being the control signal to like, I predict I will have that thing, and then if not, then I just take the difference and like do that with my motor thing. So I find that to be a really compelling idea, as like it's very simple and gets a lot done.
Yes, it's really interesting because in philosophy, you know, like we talk about value and metaphysics and epistemology and so on, and this idea of intelligence is beautiful and agency, which is that it's just about this big dynamical system where it can be modeled as if parts of it are minimizing prediction errors. But then what emerges out of that is value, you know, so what is moral and knowledge? What do we know? And what kind of relationship do you think there is between something that just minimizes its prediction errors and something that acts in a moral way or that knows how the world works?
Yeah, I don't know. I don't fully buy it, which doesn't mean that I've understood it and thumbs down it. I just haven't understood it well enough to fully buy it. That like minimizing prediction error is enough to get what I care about going. Like there's a little kid and he's in a sandbox and he's like shoveling sand, right? And the mom comes and like, we need to go to the store now, and like and he starts crying.
Yeah.
Like he cared about something with that sand. He was doing something. And like I don't know, maybe there's a great way to, like, back that out, get that from, like, prediction error reduction or whatever.
Mm.
There very well might be, but, like, I don't I think there's something important about care and understanding, like, what is lost when that kid, like, gets pulled away, that, like, I don't know if I can, like, get everything I need from prediction error reduction.
Yeah, this is so interesting because the way Carl Friston manages this is he talks about balancing energy and entropy, or,
Yeah.
exploitation and exploration. But many other people talk about it in terms of open-endedness and creativity and serendipity and interestingness. And of course, in a collective intelligence, you have many specialized agents following their own thing. Not necessarily because they're agential, they're not necessarily being pressured by other agents in the system, but that means the system as a whole discovers interesting new knowledge.
Yeah. Yeah.
Yeah.
Yeah, I mean, it's possible that, like, so one claim could be that this prediction error minimization scheme solves the entire universe, and we just have to run it super hard, and, like, all philosophical questions, like, dissolve, like, everything. I don't know if that's the claim, but, like, I wonder, like, what is the question that it leaves open?
Mm.
For me, the thing that usually is the most productive is, or most cool, is, like, having a question. And like, what's the question for at that point? What's the question?
And what is the question?
Yeah. What is the question? What is the question? Why is questioning so productive? Like, why did Descartes, like, spend that time, like, okay, so wait, what's the question? I don't know. I don't know if he said that. He's like, what, how do I know I exist? I don't even remember what he's like. He just doubted. He doubted everything, right? He just put everything into question. But, like, when we question, when we ask, like, what am I, for example, that's a great question. Like, what am I? I don't know if it's like a prediction error reduction thing exactly. It's the sort of thing that leads someone to a brilliant idea like prediction error reduction or, like, predictive processing. But just asking what I am is, like, itself somehow an openness. Yeah.
Yeah, I wonder whether this is related to the difference between ontology and epistemology, because there is just what is. There's this physical world that we live in, and the way we describe it is just using models, right? We're just modeling it, and the question seems to determine the model that we use, and it seems like you can ask a myriad of different questions.
Yeah. Yeah. But exactly. So, like, which question we ask determines that, but these questions seem to come from or arise in us, and sometimes they arise in, like, in a quiet space if we, like, meditate or, like, make room to think, right?
Yes.
So there's something about spaciousness also, like that really matter. Like, open questioning is a spaciousness that like one I think is really an important thing that in ML and, like, AI and stuff like that, it feels recently I've had this image of just, like, when I was a little kid playing soccer, I just wanted to kick the ball really hard, and I didn't care, like, about passing it to someone. It was just kicking it because, like, that's what I knew how to do.
Yes.
And, like, I want to make sure that we are, like, aiming towards something of value, and instead of saying, like, and I know what value is, to me, the thing that I love about life is that I get to, like, have some openness and have some question of my own. And so I feel like I want to maintain that there's an openness of, like, what we don't know,
Yes.
in whatever it is that we create, as opposed to, like, let's just solve it all and, like, now it'll finally be locked into place,
But I guess this comes back to the question about subjectivity. The way you framed it is much nicer, which is that there are potentially an infinite number of questions we could ask, and all of those give rise to this epistemic framework. And we can build on that framework and build on it, and it just unravels into this sea of complexity. And maintaining that openness to discover new questions, I think, is really important. But the reason it's subjective is there's no criteria for weighing one over the other.
Yeah. Well, no, but there might be. So I remember I was at some design theory conference, and the guy said, someone came up and his presentation was like, what do we owe the future? We owe them a future. In other words, an openness. Like, if we close it for them, then we didn't give them anything.
Yeah.
So, like, one thing you could ask to kind of keep open, or, like, like, what do we offer what do we want to offer? I feel like one thing we might offer is like openness of like a non-finishedness to the scheme we come up with, right?
Is it related to this idea that, you know, children become less creative as they grow up? And there's a creativity test and kids do very well on it. And a lot of that is because after lots of successive sense making, we crystallize all of these models.
Yeah.
And the way we understand the world, our space of cognition is the traversal of these crystallized models.
Yeah.
And that cone, you can traverse it in a cone.
Yeah.
And all of the stuff outside of the cone is no longer traversable. So, so it's almost like we're locking in the space of ideas.
Yeah, yeah. And so if our AI is going to lock in how we're going to see the world, or it's going to lock in how the world is going to work, then that seems no good to me. And like this thing where you're saying like, okay, now I understand what it's like to be human. Now I want to try being a tadpole. Like instead of like, oh, that's worse. How about, no, it's brand new. Like you actually get to start over as a tadpole. That's wonderful. Like keeping open, you know, whole new realms of being or something like that seems like a positive thing to aim for instead of just kicking the ball really hard.
Yeah.
Say like, no, but if I kick the ball here, will it keep an openness?
Yes.
Yeah.
But where is the wellspring of creativity? You know, where does it come from?
Yeah. I mean, it seems like, so spaciousness. So like my phone has things for me to do on it. My computer has things for me to do on it. There's all sorts of things that want my attention and that want to have access to my, what's it called? Mind share, right?
Yes. Yeah.
And it's something I have to do for myself to like keep a barrier. And that's what my skin's job is. And that's my brain. Like a lot of things, it's like a house's job is to keep a barrier from like if you're outside on the street, you're right next to all of the sounds and all of the everything, right? So like I think creativity seems to come from this privilege of having like a space in here that you will never get in here unless you're really, really bad. And so like creating space seems to be like silence or whatever, seems to be where there's still room.
Yes. And did I intuit from what you said that things like language models and current AI, not only that, technology in general, it extends our mind in quite a pernicious way. And in a way, it constrains our thinking. Is that something you worry about?
A little bit. Yeah. I mean, it's really, yeah. I've heard that if you have a book idea, you shouldn't tell anyone about it because a lot of what makes you want to write the book is like getting to say the thing. And if you tell a lot of people your story and like explain it all, then you won't really care anymore. And sometimes I feel like when I'm talking to AI, I'm like kind of getting my ideas out there and like, then they kind of like, it's okay. I don't really need to tell anybody else.
Yeah.
So I guess I worry about that. They're kind of like, they have my attention and I don't give myself space as much.
Yes.
There's like an averaging thing that like LLMs are kind of the average of all human thought in some sense. And so there's something kind of bland about them in that way.
Yeah. Yeah. It's interesting what you said about holding on to your idea. I think there's a consensus mechanism in the way we organize companies and run governments and so on. And that waters down ideas.
Yeah, exactly. Yeah. If you look at, you find there are people who make a difference and usually they do a really weird thing for no reason. Like Greta Thunberg just sitting there. I don't know how much of a difference she's made in the end or how much she will make. But one thing she did was she just like sat there, like, I'm not going to school on Fridays or whatever. But like, not just, any, some of our worst villains in history, like just did a freaking weird thing. But also creative. So I think there's something about just being like, I'm going to do this thing every day because I want to do it. And I don't have to explain why. I'm using like my investment, like whatever I have to do that thing.
And how would you model this mathematically? I mean, obviously with your background, what is the calculus for a good creative idea?
I don't know. I think so. Every idea that actually works has to work. Like that's another theory. So like it has to, like, I like the word conception, like in a biological conception is like the smallest thing that then can live in that very, very protected environment can live, right? And then if you have an idea, right? You have conception, like, but can that idea live? Does your mind care about it enough? Or is it like, oh, well, that was cool. You know, but if it can live there, it's like, if it says like, don't forget to write me down. If the idea was something that didn't say, don't forget to write me down, it doesn't find the blood supply or whatever.
Yeah.
So then so a really good idea, I think I'm really interested in self-fulfilling prophecies. If I say like, you know, you will do this thing, and then you actually do it, like that's kind of like, I will be there tomorrow at 5. I actually, by saying that, it does self-fulfill. I wasn't going to be there at 5, but then by saying I was going to be there at 5, I will be there at 5. And like, there's something about like what makes a prophecy, a prediction, self-fulfilling. So that, well, it's got to be compelling to the environment that it lives in. Like that conceived idea in my mind had to be compelling to my brain real estate. So like, if you create the transistor or whatever, you invent this new thing, it has to be compelling to, your friend who's like, yeah, I'll drive you to the venture capital, whatever. I don't know, whatever. Enough that you get the little protected thing gets driven to somewhere where it can like expand and grow. And
Yeah, I mean, it's related to persuasion. Like, for example, you could say, I want to lose weight. I want to go to the gym. I'm going to take positive actions in my life. And if you mimetically share that idea, that also creates social pressure and it becomes a self-fulfilling prophecy. But we're just thinking in terms of just psychology and humans. I could invent GPUs. GPUs created this basin of attraction, which led to all of these successive things like did the deep learning revolution and so on. So there's just this inception of the right idea just creates this massive chain reaction.
Yeah. You have to really understand the reality and what it wants to create, right? Like with conception, like the womb or whatever wants to hold a baby in it. Like that's what it was kind of made for, right? A uterus or something. But like if I'm Edison, right? He had to understand the social context of the light bulb to make a light. Like he made a light bulb, but then no one wanted a light bulb. So he had, was it him who went around with like light bulbs on his head and stuff like that? He's like, it's like you have to understand what'll make people, or Virginia Slim cigarettes, the guy who invented, the guy like Freud's nephew who like created PR or whatever. He's like, okay, women don't want to smoke because that's bad, but or they think it's ugly or whatever, but I understand the social context. I'll do this thing. So like, I'm not saying only good ideas spread. I think like bad ideas spread too. And I think it's really important that we, at this point in our lives, like have motivation where we don't just kick the ball as hard as we can, but like try to aim to a good future. But that said, like, I think understanding what wants to be created, like what good world, like imagine the world has good in it. Like hopefully you already feel that way. Then does that world need anything that I can do? And if you can find some thing that's not too hard, like you can do it. We have these little rocket boosters, like we have just a little bit of fuel, but like with my little bit of fuel, can I like create something of value for a world that I like? That's the sort of conception that can grow.
It's so strange because, I mean, Steve Jobs always said the last thing you should do is give the users what they want. And this whole thing seems to defy mathematical modeling, because you were just saying before about this chain reaction. And wouldn't it be interesting if you could predict the thing that created this chain reaction, this disruption? But open-ended systems seem to have, I mean, there was a DeepMind paper, which I interviewed the guys at ICML, and they said an open-ended system is a system that produces a sequence of artifacts that are learnable and novel. And that was their way of modeling it. So there has to be some kind of divergence. But YouTube started as a video dating website. They had no idea that it would end up the way it is. I'm not sure would have been possible to predict it.
Acceptation type thing. Have you heard of that word?
Oh no, what's that?
It's basically that like you create something for one purpose, but it's actually very well adapted, and it's kind of like pre-adapted to the thing that does something else. But I don't think I'm doing it justice, but that's very interesting.
Very cool. And eating.
Oh God, it's a tough one. And in my mathematical modeling, I find eating to be surprisingly hard. The fact that like, or hiring. So a lot of times we imagine that we are an agent and then there's the environment, and we're interacting with it. But like when you eat, this food actually becomes part of you, and starts to be a machine that does stuff. Like amino acids turn into proteins that actually do everything in your body, or oxygen. Like we think, like in some sense, oxygen is something we need just as much as we need our cells. It's just that it's so replaceable in our environment that we pretend that it's not us. But in fact, it's part of me to have oxygen around me. If I didn't have oxygen all around, I wouldn't be me. I'd be shriveled up.
Yes.
Right. So like, I find the idea of like consuming a machine to be somehow very difficult to understand.
I mean, what's interesting about this is that I think of particles of potato as being inert in the same way that viruses are inert, but you can still think of them as a superorganism, and they supervene on us. We die, viruses die. Language is also an organism which supervenes on us. So if we die, language dies. But then it becomes a modeling thing, because bits of potato, surely you can't think of them as an agent, or could you?
Yeah. How far down does agency go? And what is agency? Is agency the thing that cares about something, or the thing that just acts out something that, like a travel agent, somehow just does whatever you want them to do? They're willing to go do the hard work or whatever. So I don't know exactly what people mean by agent. When they talk about like software agents or AI agents, they seem to be talking about something where you give it a goal and then it goes and tries to get that goal accomplished for you. But like our agencies, I think you used the word intentionality earlier.
Yeah, so I would call that a strong agent. So the basic agent is, in some sense, the causality comes from inside. The thing is, we if you speak with a physicist, they would be quite horrified about this, because they just say, well, no, there's a light cone of particle interactions, and that's the only causality that matters. But you speak to a philosopher and they say, no, there's a useful way of partitioning the world up into groups of things, and we should call those things agents.
Yeah. I mean, so useful. I've been on this word care. So care, what do you care about? So there's some care words, like important is a care word. Value is a care word. Good, but another one is useful. People say all models are wrong, but some are useful. Like, what do you mean useful? Useful for what? You have to have care. And so, in my talk tomorrow, in fact, I'm thinking of like power in electricity, which is like voltage times current. I'm thinking of intelligence as the current. It's like kicking the ball hard. But care is like the voltage. It's the potential that you might be able to actualize. Like this difference. Like I could actually help that child grow up into someone great or something. And when you see some potential you want to actualize, that's care. You care about something. And I think this intentionality and care is somehow a missed part of the intelligence question. Everyone's working on the current and not the voltage. The why seems to pass through, like, I don't know what causes care to come and go. I find that to be like one of the most interesting questions, like intentionality. Some people will say like, oh, I just got imbued with some intentionality and I like strawberries more than grapes or whatever. But I think this idea of like care, like even if you do want to say everything's reductive, it's all just dopamine and serotonin and blah, 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 something puts dopamine online in a body in a physical universe. Like something spent the time to like get a system as good as dopamine going. Or like DNA has, I don't know. It has these four nucleotide bases, and then 3 of them form a codon. So that's 4 to the power 3 possibilities, but they code for 20 amino acids. So there's a mapping from like 60 to 20. That's 20 of the 60 possibilities, and apparently the one that our DNA uses is information theoretically optimal for like error reduction or detrimentalness. So what that means to me is that either God did that, or that there was a search process before genetics even got online to like get this thing working right. That all of our ancestors like got this really come. So like the intention to get that right comes before, like that's a language thing too. Like the intention to get language working goes all the way down to DNA.
There's an interesting tension between serendipity and this puritanical idea that we found the right solution. Because I read Richard Dawkins' book Selfish Gene, and he gave some examples of the way the brain evolved. All sorts of stupid things happen, like there are these big nerves that connect distal parts of the brain together, and that just shouldn't have happened, but because we evolved from monkeys and the way it is in their brain, that's just the way the way it happened. But then the question is, do you think that the way things are in the world as they've evolved, is it just quite random and we've just happened on quite a good solution, or could there be a much more optimal solution?
I think it's like, so it's you wanted to get this interview done and you found this location and it has airplane noise and blah blah blah. Like, but you want to get the thing done, but you found what is called satisficing, the Herbert Simon thing. So like it did this. You made this shape somehow when you're talking about what the brain did. It took some path, but it got the thing accomplished. And the thing it got accomplished, it found a way, or like, it found some path to that. And that the thing that it got accomplished, I don't think was random. Like having eyesight at all, or having hearing, or having those integrated, or whatever it is, the thing that you're talking about, which could be some random thing. But that thing was important enough that it like found this really long path to get it done. I don't think that it's like, I think, what I think is that there are some, I don't know what the answer is of what is actually being searched for by this global thing. Or if there's just one thing that it is, but like there are some like monotonically increasing values since the beginning of life on Earth that, like, for example, what I call high precision energy routing. So in the beginning, maybe there's just like tides and like water just flew wherever it did. And then like rabbits or whatever, like could like move their muscle and like direct the energy to like find the food. And then the food would like route itself to the cells. And now we like have, billions of voltages that are high precision routed through computers. Like, so I think if you look over time, maybe like the precision energy routing goes up and just keeps going up. Or like Carl Sagan said, the universe knows itself, like through us, we are the cosmos knowing itself. I think that amount of whatever it is that cosmos knowing itself has been monotonically increasing. So I'm not trying to say it's like philosophically, or entropy production, like long-term entropy. Like I'm not saying there's some things that seem to be trying to be made, like the universe knowing itself, if you like kind of more woo point of view, or high precision energy routing if you're like, no, I need material, like something. Even that, I don't know what high precision energy routing means, but you get a feeling for it when you think of voltages or whatever.
Yeah. What's interesting of your approach is we tend to use quite anthropomorphic language. We talk about this phenomenal sense of what's moral and what do we feel is right. But evolution itself almost has a sense of wants and values. Yeah. And through this incredible orchestra of activity, it has canalized, modularized, abstracted, created this pathway, and you're kind of arguing that it's leading somewhere.
Oh yeah. So you were mentioning Mike Levin. So I really like his work. I also like someone named Eric Smith, who is at the Santa Fe Institute. Have you heard of him? Yeah.
Yeah, I think so. Yeah.
Yeah. So he has some videos that I thought were incredible that explained like a hurricane, for example. There's a potential difference. There's a temperature difference. There's the hot ocean and there's a cold atmosphere. And there's this laminar, like layered air. And it's like, oh man, I could get so much if I could only equalize these. Well, a hurricane like somehow starts locally, but creates this eye. And that eye is just a vortex that just sucks the hot air right up there and equalizes it.
Yeah.
So he's like, nature creates pretty complex things. Rayleigh-Bénard convection, I don't know if you've heard of that, but like it can create pretty complex things. And he says that early life, he thinks he's a metabolism first instead of RNA world. I think that's crazy. I think he thinks that's crazy too. He calls that control first. Metabolism first is that life started in maybe deep sea vents where like some CO2 and H2O or something was coming out of these vents. And like life was, or maybe it was methane, I forget now. Life was the simplest, smallest little chemistry lab that could get from this high energy state to a lower energy state. And like all we've been doing is like, oh, there's some oil over there. Like, let's like get it. Like the ants are like, oh, there's a picnic over there. Let's get it. And so like this ability to coordinate action to like actualize potential is something we've developed.
Do you think we're different in any way, that we might build AI and we might build very, very intelligent AI, and we might skip quite far ahead in this process of evolution? Do you think there's something significant about that?
Yeah, sometimes I think it's like as big as multicellularity, like it's a big deal. Sometimes I think it's even bigger deal, like it's like at the level of like life creating from physics, which I don't think, I mean, how big a leap was that from physics to life? Was it infinite? I don't think it was. It was finite. So like this is also finite. Sometimes I think it's printing press level, but usually I'm more than printing press. Like I think this is more like sociality itself. Like one of the big, like I don't know, what are the big ones? So life, multicellularity, eukaryote versus so eukaryote, what? It ate the prokaryote, right? It like ate it merged with the mitochondria.
Yeah,
that's a pretty cool trick.
Yeah.
So I think I don't know how big a deal this is, but it feels to me like what's happening to me from my point of view is written language. We are able to solidify, like what makes energy turn into matter? It gets solid, right? In some sense, it seems like spoken language is just action. We're just like moving around our bodies, and one part of our body is a voice box that vibrates fast. But when you write it, it becomes solid in a certain sense and can be passed around as a solid. And that happened, what, I don't know how many thousands of years ago.
Yeah.
We got written language. I think that was like, then we're like the printing press, but printing press is just written language, but faster. And I think AI is also just written language as a thing. Like the last time that happened was DNA. DNA is a written language. It's ACGT, and it makes it's the building blocks of every protein in your body, everything in your body, right? It's the code for it. Doesn't mean it does everything. Like the cell does stuff too, but so the environment does stuff too, but written language is a big deal, and it feels like the second time that's happened.
Yeah, it's interesting because it's a phase change. So DNA was a form of mimetic information sharing. Language was a form of mimetic information sharing, which started about, let's say 100,000 years ago. And it just created this dramatic kind of social complexification.
Yeah.
And it triggered our brains to grow very large. I mean, if you're a fan of the social theory of language, I mean, I certainly am. But you think AI could be the same again?
Yeah, and I think I'm differentiating written language. I'm not sure how important that is. Maybe it's not that important, but like something about written language turns it from just an action into a frozen artifact that can be manipulated like a tool or something. It's something like a termite can work with rocks, but it can't work with language. I don't know if it can. But like, I don't think it manipulates the pheromones or whatever that it's using to like decide where to deposit the rocks as an object. But when you make written language, you get an object. I feel like something's different about that, but I'm not sure.
Yeah, is it like the memory and the plasticity? So now knowledge can survive many generations. So we're building on the shoulders of giants. But the thing is, like DNA is really slow.
Yeah.
Whereas language, I mean, you can acquire new knowledge right now.
Yeah, it's kind of like eating again. When you hear something I'm saying, or I hear something you're saying, I can eat that, and like that starts to not just be a fact in a knowledge base, which is why I don't really love the word knowledge. It's like it becomes like a machine that can act on new information and transform it.
Yeah.
Yeah. And so like how does language work? Like plus, what does plus mean? It means you have two groups of cows and a fence between them, and you remove the fence. That's plus, right? But like that's how plus works. It works like removing a fence. Yeah. Whereas times works by making a grid. You have like this by this, and you like have two options instead of like these two options. The rules of plus and times just follow those activities of like making a grid or like removing a fence. And now everything I do with those plus and times very, very quickly is like doing all these crazy, manipulations of fences or whatever. I think language like lets us experiment really quickly. Like that didn't sound right. The way you said that didn't sound right. I don't know what it was, but it didn't sound right. It's actually telling us about like a simulation that we could run and see a problem with that.
It's weird as well, because when you look at the phylogeny of culture and language, it's very divergent, it's gnarly. I mean, as a mathematician, it might horrify you just how many inconsistencies there are. Yeah. Like, how do you juxtapose that in your mind between, we want to think that there is like a code of the universe, there's some abstract structure that generalizes in all possible situations, but things like language, it doesn't seem to work that way.
Well, when someone's speaking, and they're making all sorts of inconsistent, like if I think about myself in this interview, I'm sure I'm like weaving all over the place. I hope it makes any sense at all. But like you start to get a vibe, right? Like, I don't know what you just said, but I think you were being mean, or I think you were not you. Yeah, I was pointing over there. Like that's a feeling that you can get, and then you're like listening, and then you hear it again, or like you taste that taste again, right? And so like you don't have to. I think language is more like an attractor. It's like E equals MC squared is an attractor for people who want to say physics fast, right? Yeah. Like I wanted to say physics fast, so I said E equals MC squared. Like it brings you in and then lets you be there for a while and just point at something. And so I think like language, even this natural language you're talking about, where it's like woolly and wild and no one knows what it really means, it's still attracting our attention, and we can watch where the person is moving our attention. And we can feel them like proving that they're smarter than us, or we can check that we can feel them like saying they're offering something to us, or whatever they're doing. We can start to be attracted into that basin of our like understanding of what this interaction is supposed to be.
Yes.
Yeah.
David Spivak, it's been an honor to have you on. Folks at home should check out your MIT category theory. It
still exists.
It's on the Topos Institute channel.
Topos Institute channel has it all now. Yeah,
it's really, really good. So folks at home, please check that out. And David, it's been an honor. Thank you so much.
It's been great. Thanks a lot.
Awesome.
Yeah.
Well.